This is Ham College, episode 109, for January 26, 2024. Ham College is brought to you by Icom. Keep your competitive contesting edge with Icom. Icom's innovative and high-powered base stations cut through polyps, letting you work the bands and record those contacts. Heard it, worked it, logged it. Good evening. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And boy, do we have some questions for you tonight.
Some hard questions.
We'll see. They were hard last month. I remember that. What did we talk about?
Some difficult topics. I think we talked about Yagi antennas, parabolic reflectors, circular polarization, loading coils, top loading, feed point impedance of electrically short antennas, antenna Q, and maybe a little bit of RF grounding through in there for good measure.
That sounds like something we would talk about.
For good measure.
Yeah. So they'll be easier this month because all we're going to talk about is matching antennas to feed lines, phasing lines, and power dividers.
Ah, fun stuff.
Yep. Useful stuff, too.
Yeah.
It'll all make sense as we go through it. We got a little explaining to do.
It's easy for him to say.
Well, I got it out that time. I don't know. I don't know how it's going to go, but we'll find out. You know, anytime we're doing a show live, there's a chat room going on at the same time in YouTube. The YouTube chat is what we use, and we'll be checking the answers people are feeding us in there as we go through the show tonight.
Yep.
And kind of compare and just see how we're doing.
We used to say if you were watching the live feed, but you weren't in the chat room, you're missing half the fun, but it's kind of hard to miss the chat now.
Well, it kind of is.
In the YouTube chat.
Yep. Well, let's see. I think you took the first one last month, so I'll do you a solid.
Okay. What system matches a higher impedance transmission line to a lower impedance antenna by connecting the line to the driven element in two places spaced a fraction of a wavelength each side of element center? Whew. A gamma matching system.
B, a delta matching system.
C, the omega matching system.
Or D, the stub matching system. What system matches a higher impedance transmission line, to a lower impedance antenna by connecting the line to the driven element in two places, spaced a fraction of a wavelength each side of center? So if this is my element, I'm not breaking it in half. I'm connecting in two places.
Not in the middle.
A fraction of a wavelength. All right. Answer's a gamma match. No, there is such a thing as a gamma match, but that's not what this is. D, stub matching system. There is such a thing as stub matching, but they're not talking about a stub there. C, the omega matching system. I don't even know if that's a real thing or not.
I've never heard of it. I've heard of the other three, but I've never heard of omega.
B, the delta matching system. That's going to be my answer. And the reason I'm saying that is because our element's going across and we're feeding it two places, and that's kind of like a triangle or like a delta. So
okay,
I'm going to say it's a delta matching system.
So is that where they get that term from?
We'll see. Little mix in the chat room. Not many folks answering it.
That's when they get tough when they don't answer. That's when you start kind of sweating it out a little bit.
Yeah, they're saying a different answer than I did, so I don't know. Maybe I'm full of it. Let's see. No, it is a delta matching system.
I'll give you that.
Okay, I needed that too. The delta impedance matching is often used with antennas like a Yagi to match a high impedance transmission line to a low impedance antenna the name delta match comes from the actual shape of the matching configuration. Yeah, and if you look there, see we got a piece of ladder line going up and then it splits out left and right and connects to the element, and that forms a delta right there. That's where they get the name delta match. You wouldn't think that would work, but apparently it does.
It doesn't seem like it should work.
No, it looks like it'd be shorted out, but I guess there's some ciphering you have to do to pull that off, and I don't know it.
It's actually pretty amazing if you think about that it's not a dead short.
It is. But, you know, it's all about frequencies and wavelengths and all of that kind of stuff, so somehow it works out.
Weird.
But delta, because it's, you know, a triangle.
Peace.
Okay, I got one for you.
All right.
What is the name of an antenna matching system that matches an unbalanced feed line to an antenna by feeding the driven element both at the center of the element and a fraction of a wavelength to one side of center? A gamma match.
B, the delta match.
C, the epsilon match.
Or D, the stub match. What's the name of an antenna matching system that matches an unbalanced feed line to an antenna by feeding the driven element both at the center and at a fraction? So basically what you had before, you just one of them was moved to the middle. Well, I know for sure it's not a delta match. I don't know what an epsilon match is. And I'm assuming a stub match is similar to the stub that we cut for the filter somehow on that. So I'm thinking it's going to be A, the gamma match, because it's not the other ones.
That's a good way to figure it out.
Yeah.
I'm not even sure what an epsilon match is. I don't know
I've
if
never
there's
heard of
such
such.
thing.
Yeah, but because I haven't heard of it doesn't mean it doesn't exist, but I've never heard of it.
I'm going to agree with you, as does the chat room. Tom says epsilon match. Are we going to have a sigma chi match in a bit?
The fraternity match.
Maybe. I think you're right.
Okay.
There you go.
Yeah, it's going to be the only one of those I get tonight.
A gamma match is a form of match where the shield of a coaxial cable is connected to the center of a half-wave driven element. The center conductor from the coax is fed through a variable capacitor to an off-center feed point. Here the impedance will be higher than if the half-wave antenna had been broken in the center like a normal dipole. The capacitor tunes out the inductance of the arm connecting the coax center lead to the antenna element. One of the advantages of a gamma match is that it's unbalanced and can be driven directly by coax without the need of a balun. The gamma match is actually half of what's often referred to as a T-network or T-match.
What is the name of the matching system that uses a section of transmission line connected in parallel with the feed line at or near the feed point? A, the gamma match.
B, the delta match.
C, the omega match.
Or D, the stub match. I bet you can guess this one.
That's pretty much a freebie right here.
Yeah. Well, we know it's not the gamma match because we know what the gamma match is. It's not a delta match because we know what that is.
It's not an omega match because nobody knows.
But D, the stub match. I mean, you're right. That's a freebie right there. A section of line connected in parallel with the feed line at or near the feed point. That just says it all. The chat room, everybody's saying D in there. Stub matches are often used to match the load to a transmission line. They're made of shorted or open segments of transmission line connected in parallel or in series at the appropriate distance from the load. Shorted stubs are desirable because open stubs can radiate from their open end. And that's a stub match right there. And it's all about what's being reflected back from the antenna and the distance between the antenna and where the stub is, and the length of that stub affect the match. It is a fairly common type of match.
People really use that?
Yep.
If you use that, send me an email. I want to see a picture of it.
Okay. Well, we talked all about stubs.
Yeah, I remember the stubs, but that wasn't a match. That was for filtering.
It could be used
Kind
for a
of like
match
a notch
too.
filter type
Yeah.
thing.
Yeah. But, I mean, that was pretty straightforward, though, the question. I mean, you could reason out why.
Sure.
Yeah. What is the purpose of the series capacitor in a gamma-type antenna matching network? A, to provide DC isolation between the feed line and the antenna.
B, to cancel the inductive reactance of the matching network.
C, to provide a rejection notch that prevents the radiation of harmonics.
Or D, to transform the antenna impedance to a higher value. Purpose of a series capacitor in the gamma type antenna matching network. I don't know. I'm going to go with B, man. I really don't know.
B.
Yeah. I want to say
Look at
A.
there.
No way.
You totally redeemed yourself.
No way.
Here, let me give you another
I
one.
don't deserve one for that.
You weren't going to choose that, but you did. Do you know why you chose it?
Because the other ones didn't really make much, they didn't seem like they should be the right answer.
Yeah. But if you needed to cancel some inductive reactance, what would you use?
Capacitor.
There you go. Just,
But A,
yeah.
I mean, A would work, but I didn't know why you would want to do that.
No, you wouldn't. You wouldn't necessarily want to do that. But it would isolate it DC wise, but that's not something you're really concerned about. It was not good in the chat room.
Wow.
There was one who got it right.
It's pretty tough, man.
Most of the folks aren't answering these this week.
Yeah, I don't blame you. If I should have got General Lee Cheap to sit in for me this week.
I don't know, man. No buzzers yet.
The night's still young.
Yeah.
How must an antenna's driven element be tuned to use a hairpin matching system? A, the driven element reactance must be capacitive.
B, the driven element reactance must be inductive.
C, the driven element resonance must be lower than the operating frequency.
Or D, the driven element radiation resistance must be higher than the characteristic impedance of the transmission line.
Ooh, I'm glad you got this one. Driven element reactance must be capacitive.
How must an antenna's driven element be tuned to use a hairpin matching system? It's a little hard for me to say why the wrong ones are wrong. The driven element radiation resistance must be higher than the characteristic impedance of the transmission line. No. See, the driven element resonance must be lower than the operating frequency. No. The driven element reactance must be inductive. B. No, because a hairpin match is going to add inductance. A. The driven element reactance must be capacitive. Yes, that is the answer, because a hairpin match is going to give us some inductance. So if the antenna was a little capacitive, adding some inductance would help cancel that out. I'm going to go with A. Chat room, they're kind of mixed on it.
Yeah, I told you these are tough tonight.
Yeah.
Wow.
So if we've got a piece of coax coming up to a dipole antenna there, you see there's an inductor at the top of it. That is a hairpin match. it may be a coil there to do the matching, or it may just be like,
a piece of folded wire.
yeah, wire going up and, just like that.
Yeah, I made one out of Romax for my tape measure antenna.
Well, then you knew the answer to this one.
No, I just followed the instructions.
Oh, you didn't know it was a hairpin.
I knew it was a hairpin. I just don't know why it was. Well, I don't know why I made it.
Oh, well, there you go. To get the capacitance out of that tape measure.
Actually, I think it did explain that in the instruction. It's been so long. Mike says, isn't that a beta match? It says it right there in black and white.
Hairpin or beta match. What do you say we take a break? Come back in just a minute and continue on with these.
Keep your competitive contesting edge with Icom. Icom's innovative and high-powered base stations cut through polyps, letting you work the bands and record those contacts. Heard it, worked it, logged it. The Icom IC7300 is an industry first, using an RF direct sampling system and an entry-level HF radio. This compact, high-performance, innovative transceiver will far exceed your expectations. The real HF fun starts here. RF direct sampling, 15 discrete bandpass filters, 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The Icom IC7610 is the SDR every ham wants. Faint signals are no longer a challenge for contesters or DXers. The high-performance RMDR can pick out the faintest of signals, even in the presence of stronger adjacent signals. This direct sampling software-defined radio has changed the world's definition of an SDR transceiver. RF direct sampling, 110 dB RMDR, independent dual receivers, and dual digicell. Keep your competitive contesting edge with the Icom IC7851. Contesters and DXers are always looking for that competitive edge to magically pull out the weak signals needed to climb up the list. With faster processors, higher input gain, higher display resolution, and a cleaner signal, the IC7851 is the pinnacle of HF perfection. 110 RMDR, 1.2 kHz optimum roofing filter, digital IF filters, digital voice recorder, high-resolution spectrum waterfall display, enhanced PC connectivity, and SD memory card slot. For more information about Icom's amateur radios and to locate a dealer, please visit icomamerica.com/amateur today. For the love of ham radio.
Well, Tommy, what do you say we give away something?
Hey, how about this shirt?
That sounds like an excellent idea. And you can ship it out after the show tonight.
Yeah. Here, let me go ahead and...
That's okay.
Yeah, nice Icom Ham Crew t-shirt. Can you see it?
You can see it. Yep. The shirt was in the way?
No, the chair.
Oh, no, it was okay. It was good.
So you can look this good.
If you wanted to win that, how could you do that?
It's really pretty easy. Very little requirements. You don't even have to have a license. Just send an email, hamcollege@AmateurLogic.TV, and all you really need is a name and an email address.
That's pretty much it.
If you want to put a note in there, that'd be great. We like to get them and read them, but if you don't, that's cool too.
Okay. Well, this month's lucky winner, drawn by random drawing. The winner did not give us a message in there.
That's okay.
Although
he still wins.
We did get a name. It's Robert Evgen, or something kind of like that.
Evgen? EVJEN?
Yep.
Cool.
He did put a subject on there. He said, for the win.
There you go.
Icom will be getting out a package to you with a Ham Crew t-shirt, along with some other goodie stuff in there as well.
Cool. If you didn't win tonight, the queue's been cleared out. Go ahead and start sending your entries in for next month. Maybe you'll get it next month.
Yep. So, it could happen.
Thanks to Icom for sponsoring that. They've been doing it for a long time. I guess since we've been doing Ham College, haven't they?
Pretty much, yeah.
Yeah, so appreciate them.
Which of these feed line impedances would be suitable for constructing a quarter wave Q section for matching a 100 ohm loop to a 50 ohm feed line?
Oh, man.
A, 50 ohms.
B, 62 ohms?
C, 75 ohms.
Or D, 450 ohms? Which of these impedance would be suitable for constructing a quarter wave Q section for matching a 100 ohm loop to a 50 ohm feed line? I'm going with C because I don't think it's going to be 50.
Yeah. If you're using 50 ohm line, could you even make a 50 ohm quarter wave Q section?
Don't seem
I
like
mean,
it.
it'd just be 50 ohm line.
Right. I
yeah.
don't think 450's right either. And 62 is an odd number because 50 and 100 is a multiple. I'm going to go with C, 75 ohms, but I don't really know.
I'm going to agree with you, and that's what they're saying over in the chat room. It is C, 75 ohms. Quarter wave of 75 ohms would transform that impedance to where it'd be right. Be 100 ohms when it got to the loop.
It's kind of clicking something. I seem to remember somebody doing something with this.
Alan.
Oh, yeah.
Yeah.
That sounds like something Alan would do.
Yep.
What parameter describes the interactions at the load end of a mismatched transmission line? A, characteristic impedance.
B, reflection coefficient.
C, velocity factor.
Or D, dielectric constant. What parameter describes the interactions at the load end of a mismatched transmission line? All right, the load end would be the antenna end. So it wouldn't be the characteristic impedance. That's talking about the impedance of the line. Not what's on the load. It wouldn't be dielectric constant. That's talking about the line, and so is velocity factor. That's talking about the line.
Diameter of the wire.
So reflection coefficient, because we are talking about a mismatch and we would have a reflection there. So it would be reflected power, and a reflected coefficient would describe that. I'm going with B. What do you think?
Yeah, I think so. I don't think those others are it. That one seems to make sense.
Everybody in the chat room is saying B. Everybody
Must be
that's
B.
answering.
Must be B.
Let's see. It is.
Let's B.
Okay.
All right. Way to go, everybody. Knuckle bump for everybody.
Yep. Tom was really excited about that answer because he answered it 4 times. B. Either that or he was doing a Bing Crosby song. What did Bing Crosby? I don't know.
I don't know. Yeah. I know what you're talking about. Maybe.
I'm not sure I do, but yeah. What is the use of a Wilkinson divider?
To divide your Wilkinsons.
It wouldn't. I wasn't expecting that. It would do that, though, I guess. A, it divides the operating frequency of a transmitter signal so it can be used at a lower frequency band.
Or B, it's used to feed high impedance antennas from a low impedance source.
C, it's used to divide power equally between two 50 ohm loads while maintaining 50 ohm input impedance.
Or D, it's used to feed low impedance loads from a high impedance source. Well, since it's the Wilkinson divider, everybody knows that that's going to be C. It's used to divide power equally between two 50 ohm loads while maintaining 50 ohm input impedance.
Yeah.
But I really don't know. I'm guessing. I don't know what the answer is. I've never heard of a Wilkinson divider. But C seems like it's plausible.
I've never heard of a Wilkinson divider either, but I have heard of a divider. As a matter of fact, I've used them.
What do you divide your Wilkinsons with if you don't use a Wilkinson divider?
You could use a Johnson divider, I guess. I don't know. But apparently a Wilkinson one, well, let's see what everybody over in the chat room is saying. They're saying C.
Or C or D.
Yep, or C or D. I'm going with C. You got it.
Oh, I got it.
Yep. I told you you're going to
Well,
get
it
these
says
tonight.
divider. It's the only other one that says divider in
Yep.
there. I mean, I could see why you would want
Yep.
to do that.
We use on AM broadcast stations that are directional where we've got multiple towers out there.
Mm-hmm.
Part of the matching network, because there's only one transmission line that goes to a phasing cabinet, and part of what's in that phasing cabinet is a power divider that splits off how much power is going to each tower, and it also does the phase and such too. But here, I guess what distinguishes this as a Wilkinson is because the power is equally divided between 250 ohm loads. But divider like I'm using in broadcast, those are most of the time that's not equal. It's a little different power going to each tower on purpose. So
But can you tune it to be 50 even?
yeah, that's kind of part of why it's there. There's a part of it that's called a common point for common point impedance, and you use that to match it. So if you're coming from the transmitter, I'll start on this side. If you come from the transmitter, the first thing you'll run into is the common point impedance network that matches whatever's after it to 50 ohms back to the transmitter. Then you'll have a power divider that divides it up, however much should go to each of the towers. And in that, you'll also have some phasing, which shifts the phase, whether it should be positive or negative going to each particular tower. It gets more complicated on that, but I don't have to build those. I just maintain them.
Which of the following is used to shunt feed a grounded tower at its base? A double bazooka match.
B, a hairpin match.
C, a gamma match.
D, all of these choices are correct.
You should know this one right off the top of your head.
Which of the following is used to shunt feed a grounded tower? Now, a grounded tower at its base. I don't know if they worded this very understandably.
Grounded tower.
Which of the following is used to shunt feed a grounded tower at its base? Well, I'm thinking you're talking about a tower that's grounded at the base. I could be wrong, but it's not a double bazooka match. I don't think that's the thing. There's a double bazooka antenna. But I don't know that that's a match.
So you're saying it's not D then?
I'm saying it's not A and it's not D. Right. So it's either going to be a hairpin match or a gamma match. And let's see, a hairpin match, that would be like we were talking about an inductor or a piece of Romax or whatever.
The gamma match has a capacitor.
A gamma match has a capacitor. I'm going to go with gamma match.
Yeah.
It's either B or C. I'm going to say C.
I think I would have guessed C.
So, chat room, what are they saying? A little mixed. B or C? It is C. Oh, and a lot of words.
Oh, yikes.
Which of these choices is an effective way to match an antenna with a 100 ohm feed point impedance to a 50 ohm coaxial cable line? A, connect a quarter wave open stub of 300 ohm twin lead in parallel with a coaxial feed where it connects to the antenna.
B, insert a half wavelength piece of 300 ohm twin lead in series between the antenna terminals and the 50 ohm feed cable.
C. Insert a 1/4 wavelength piece of 75 ohm coaxial transmission line in series between the antenna terminals and the 50 ohm feed cable.
Or D. Connect a half wavelength shorted stub of 75 ohm cable in parallel with a 50 ohm cable where it attaches to the antenna. Which of these choices? Wow, that's really wordy. Made my eyes start twitching when I saw
Yeah.
which of these choices is an effective way to match an antenna with a 100 ohm feed point impedance to 50 ohm coax feed line? To have a quarter wavelength stub, open stub, 300 ohm. Insert a half wavelength piece of 300 ohm twin lead series with the antenna terminals. I'm going with C. That's a guess, but I'm going with C. I have no idea if that's right.
I'm going to go with C as well. The chat room, Mike said use a 2-to-1 balun. But
That's not up. I couldn't see that up there. Maybe it's off the bottom of the page.
I think if you use C, you would have a virtual 2-to-1 balun. Look at there.
Wow.
You know, this is the same as the question we had earlier.
Yeah.
Well, I say it is. What was that other question?
Well, it has the same values as the other question. And that's what I was kind of thinking back when I chose this one.
Which of these feed line impedances would be suitable for constructing a quarter wave Q section for matching a 100 ohm loop to a 50 ohm transmission line? And it was 75 ohms.
Yeah.
So
And the
quarter wave, 75.
The other one was 75 too. What's the primary purpose of phasing lines when used with an antenna having multiple driven elements? A, it ensures that each driven element operates in concert with the others to create the desired antenna pattern.
B, it prevents reflected power from traveling back down the feed line and causing harmonic radiation from the transmitter.
Or C, it allows single band antennas to operate on other bands.
Or D, it creates a low angle radiation pattern. Well, let's get some things out of the way. It's not going to change the angle of radiation. What's the primary purpose of phasing lines?
Power, you mean?
Yeah. Well, I happen to know kind of what a phasing line would be. It'd be like sort of like that antenna phaser I was talking about earlier.
Mm-hmm.
You're using a piece of line to shift the phase between multiple antennas. You just change the length of line between them, and that changes the phase of the power getting to them. A, it ensures that each driven element operates in concert with the others to create the desired antenna pattern. I think that's the answer. Let's look at the others. B, to prevent reflected power from traveling back. Now, scratch that. C, it allows single band antennas to operate on multiple bands. Now, it's A. That's not the way I would have worded it, but that's...
Yeah, but that's the only one on there
thing
that seems like it would even be close to right. It's low angle radiation pattern, that doesn't seem right either. So
everybody got that in the chat room, eh? And they did. And you know, that was the last question for tonight.
No way.
Somehow we got through unscathed.
I just don't see it happening, man.
Yep. Speaking
Stranger things have happened, I guess.
Yeah. I'm sure they have. Right here, as a matter of fact. Let's say you went to a ham fest.
Next weekend.
Yep. And everybody was fighting over your shirt, and you didn't and you didn't come away unscathed.
Yeah.
What would you do?
I'd figure out how I was going to explain that to my wife when I got home.
True. Yeah, that'd be one thing. But if you needed a replacement, not necessarily the shirt you've got on your back,
But another cool one.
But another cool shirt.
Because
Yeah.
all I wear are these cool ham shirts.
Yeah.
I'd probably go to shop.spreadshirt.com/AmateurLogic and I'd get myself some cool threads there.
Mm-hmm.
Might pick myself up a coffee cup or a backpack. If it's chilly, I might need one of those hoodies.
You could. If it's raining or sunny, you might want that hat.
Yeah.
Shop.spreadshirt.com/AmateurLogic. Throughout the month, if you wanted to catch up on what's going on with Ham College, AmateurLogic, or the group in general, you could do that by going to facebook.com/group/hamcollege.
Yeah, you can follow us at Ham College on Twitter.
Or you could subscribe to groups.io/g/AmateurLogic, and you'd get a notification whenever we post something, which is mainly just when there's going to be a live stream and when a new episode's been released.
Yep.
Speaking of groups.io, I got an email today. Did you get that?
I got a bunch of them over the last week about having to revalidate my email address to stay in some of the groups that I'm in.
Yeah.
Yeah, so if you get that, I mean, I guess that's legit from them.
Yeah.
So anyway, if you want to stay in the group, probably need to go through and revalidate and do whatever the steps
Yeah.
are.
Basically, all you got to do is log in, and I think it'll walk you through it. So just log into groups.io. I don't know that you specifically have to, go to each group that you're a member of. I think you can just do it once, and
Yeah.
I believe. Although they sent one today, we can go on and look and see who subscribed in our AmateurLogic group, what their state is, whether or not they've, reinitialized or whatever the word is to validate.
Revalidate their email address.
What actually happened? Did you see that?
I haven't
While they're
read
doing
it
that?
all yet.
Somehow groups.io ended up on the spam house list of banned websites for sending spam.
Great.
Because somebody subscribed to something on groups.io and then marked it as spam. That put them on a list. If you subscribe to any of these things and you don't want it anymore, just go unsubscribe. Don't mark it as spam.
Yeah, it's easy to do.
Yeah, easy enough to do. And then
it wasn't our group. I mean, that's just in general.
No, it was in general.
Groups.io.
So they're just going through and asking everybody to revalidate their account so that, they can prove that we're not sending spam out.
So all our people in our groups are way cooler than that. Wouldn't do that.
I would say so.
You know it.
It's a sharp bunch of folks.
Heck yeah.
And then there's us.
I wasn't going to go there.
Yeah. So what if you wanted to know what episode, like, say maybe you didn't remember that last month we talked about Yagi antennas, parabolic reflectors, circular polarization, all that stuff.
I know what you can do. You can go to the wiki.
Oh.
AmateurLogic.TV /wiki, and you can put a search, whatever you're searching for in there, and it'll pop up.
Okay.
Works pretty good.
Yep. For AmateurLogic or Ham College, either one, they're both at the same address there. And that's about all we got to say about that. You want to visit with the chat room for a moment before we go? See what's going on? Nigel does point out there's a problem with the hats and emails dog eating them. Yeah.
They're tasty. They're tasty hats.
I haven't tried one.
I mean, either, but apparently the dogs really like them.
Yeah. I keep mine out here in the shack. I don't bring it in the house. No need to tempt fate.
Is that your dog's name?
No. Oh, some things it could be, though. Tom says these questions were a lot tougher for me to answer tonight because I don't use any kind of matching system except for a 419 to 1 broadband impedance transformer, aka EFHW Unan. In-fed half wave. Okay. I didn't realize that was 419 to 1 on those.
Yeah, me either. Yeah, speaking of at the Hamfest, the Jackson Hamfest is next weekend.
It is. I'm planning on going.
Yeah, I'll be going.
Oh, tomorrow is Winter Field Day.
Field Day. Tomorrow afternoon through Sunday afternoon.
Yep. That, I've always said I wanted to do that,
Yeah,
and I would,
but
but I just had cataract surgery this week. So, these glasses right here, I've got a lens missing, and I'm still too close in to be doing much lifting and strenuous stuff. So I'm wimping out.
I'm gonna go out. I don't know if I'm taking out that IC 905 for sure. I may take my 705 too, but I'm not gonna go for the whole 24 hours. I'm probably just gonna set up either in the yard or go to the park close to the house.
I guess that's going to do it for tonight, unless you've got some further expounding that.
No, I was trying to think if there's anything else we needed to cover, but I think we got it.
Well, let's see. Do we know when the next Amateur Logic is going to be?
Probably not.
Probably the 9th or the 16th
I'm
of
voting
February.
for the 16th.
Yeah, that's sounding better to me.
All right, it's
All
time
right.
to go find some supper.
7-3, everybody.
7-3. Catch y'all guys in a couple weeks. Maybe we'll see some of you at the Jackson Ham Fest if you're close by.
No, because a hairpin match is going to add reductance. It's going to add inductance.